Right, let's carry on with part 2 then and start talking about load balancing. So we talked about reverse proxying. So there we've got our front-end instance, our back-end instances for different services. In load balancing, things are slightly different. We still have this front-end system, but now our back-end instances are essentially carbon copies. They're exactly the same thing on each one, whereas before they were different services. So again, taking an example from Apache, this box is somewhat virtual in that we do it with DNS round robin, and then we've got 3 instances of our websites, and those servers handle all of the Apache project websites, the main Apache websites, and a handful of other domains as well. And you can actually go directly to those domains if you want and surf the Apache website. So here, essentially, we've got more load than any one box can handle, so we spread it across. And it also allows us to take individual boxes offline, handle failover or node failure fairly gracefully. So it still looks like a single host. There are still multiple hosts, but each host is the same. Also, each host is independent. So from those back-end hosts, this host has no visibility of what's going on this host, and vice versa. Oops, too far. There is no shared state, and whatever state there is confined to a single host. Shared state is where we get into what Tomcat calls clustering. Now, those hosts, they might share some common services. Could be authentication, could be a database. If they do, there's probably a whole other load balancing solution going on to ensure that that service is reliable and not subject to a single node failure as well. And depending on what goes wrong, how things are configured, if a node fails, it may or may not be transparent to the user. Really, it depends on partly how the load balancer is configured, partly what the user is doing at the time. So if you've requested a static resource, the back-end node fails for some reason, the load balancer detects that, it can redirect that request to a different node, and you'll get the response back. So as far as you're concerned, you probably won't notice the failure. However, if you're in the middle of doing something that involves state, node fails, state's lost, load balancer may redirect you, but it redirects you to a node that's got no idea who you are or what you were doing, at which point you certainly do notice as all of your states disappeared. So depending on what's happening and what's going on, that may or may not be visible. There are lots of options for spreading the load around. So you've got hardware load balancers, we've got the option that Apache uses, which is the round robin DNS. You've got software load balancers. I know you've got HTTPD, which is the one I tend to use. For small development testing, there's a very simple one called Pen. That's not something I'd recommend for production. It's more of a quick thing for developers to use.
HA proxy.
Yeah, HA proxy, just loads, F5s. What I will say, the difference between a hardware load balancer and a software load balancer is not quite that black and white, because let's face it, a hardware load balancer is just a PC inside with some special software on it 9 times out of 10. Sometimes they might have dedicated hardware, and those tend to be towards the higher end of the market. But really, the distinction I'm trying to make there is there are some boxes that will only do load balancing, and there are some that are basically it's software you can download and run on any generic box. But fundamentally, what they're doing it exactly the same way, and they don't look that different. So the things we're going to look at for load balancing, we'll have a quick look at some terminology. We'll look at how requests are distributed. We'll look at our options for managing state, what happens when failover happens. And again, questions, feel free to ask them as we go along. So the terminology I want to talk about is sticky sessions. And this is a concept you'll come across when you're using load balancing and you haven't got back-end clustering. And what happens is, ignoring clustering, so we're talking about a situation where we're just doing load balancing, you do something that results in the app needing to create a session. That session is created on the node you happen to be using. Your next request really needs to come back to that node where your session is. But the load balancer, by default, is probably just going to spread it around to one of the other nodes. So there needs to be a mechanism, and sticky sessions is the name given to that mechanism, to make sure that once a session has been created on a particular node, all subsequent requests for that session go back to that node. That way the user doesn't see their state suddenly disappearing in a puff of smoke. And there are a couple of different ways of doing that. Come on to that in a little bit when we talk about more about request distribution on the next slide, I think. So how can a load balancer decide how to distribute requests? Well, pretty much any algorithm you can think of, you can implement. HTTPD, I believe, has got pluggable load balancing algorithms, but the ones it ships with requests. So assuming that all requests are roughly the same size, then number of requests is a reasonable approximation to load, so just do it by requests. Maybe some requests are bigger than others, and bytes returned is a better estimation, so use that. You can do it on number of concurrent requests. There's also a new module in HTTP4, the one that does the back-end pings, whose name I can't remember. Yeah, that one. I'll look it up in a minute. But HTTP mod proxy, there's a module that will actually let you communicate the status of the back-end service to the front end, and then you can make load balancing decisions based on real load information from the back end rather than what you think it might be. ModJK can do all of the above, plus it will also has a way of estimating the sessions. Now, it is only an estimate, because sessions can time out without ModJK users can just disappear without ModJK knowing. So it is only ever going to be an estimate based on the traffic that goes past. And again, sessions may or may not be a reasonable estimate for the load that's on your particular system. Other things I've seen used, the last octet of the client IP, that can work, but you do need to be careful depending on who your clients are. Something we've come across at the ASF is there are quite a few large technology companies out there that access the internet through a fairly small IP range, sometimes just one or two addresses. And you can have sort of hundreds of thousands of users coming from a single IP. ISPs are much the same. So you can have lots. So if you're doing your request distribution based on the last octet of their IP and you happen to hit one of these blocks, then one server is going to get an awful lot more load than the other. The way we tend to come across it at the ASF is we've got some fairly aggressive abuse protection in place, and you abuse one of our servers, we knock you off all of them. So it only takes one developer in a big technology company somewhere in California to do something silly like decide, I know, I'm going to pull down the entire history of Apache's SVN server, all 1.8 million revisions of it, with a simple SVN up, because what could possibly go wrong with that? Well, what could go wrong with that is we'll spot you doing it, we'll block you and your 999,999 colleagues, at which point your IT department gets a little bit upset. So client IP, you need to be careful, and AOL historically is known for having lots of clients behind single IPs as well. So you might not get the distribution you're looking for. If you're doing it in an internal environment, it's probably safer. Other things I've seen, last digit of a customer's account number. You get routed to a particular node based on that. I've even seen companies do it based on customer type. This was a banking customer of mine. Not one I bank with, one I was consulting for at the time, I hasten to add. And quite simply, the customers that had lots of money got sent to the more powerful, less used cluster, because they wanted them to have a nice, responsive, pleasant interaction, and they wanted a much lower risk of it going wrong. Because if one of those clients decided, right, I'm fed up with ... bank systems, it keeps crashing, it's slow, I'm taking my large sum of money elsewhere, that would have been a big deal for them. So they made sure it didn't happen. And so lots of different ways you can do it. Now, in terms of managing state, the thing that complicates load balancing and leads you in the direction of clustering is the fact that applications have state, and you need to manage that, maintain it, make sure the users can access it. If you can actually forget state completely, that's by far the simplest solution. If you can make your app stateless, great. Unfortunately, that doesn't happen very often in the real world. It's a nice idea, it's a nice theory, but usually there is a need for state of some form, and bearing in mind that state includes simple things like authentication. Now, there are options. Basic authentication is a good example where you maintain the state where actually you send the authentication credentials on every single request, and they get validated every time they need to be used. So actually the server isn't maintaining any state there. You're basically re-authenticating every single time. You can do it with HTTP session. That's a fairly standard way. You can push the state into a database. Now, if you've got relatively small state that changes relatively infrequently, pushing into the database could be an option. The bigger the state, the more often it changes, the greater the load that's going to put on your database, and at some point it's going to reach the point where it's just not viable. Whether your app reaches that point or not is something that you'll have to test for your app. Something else is you can push all the data into the request parameters. You sometimes see apps pushing stuff back and forwards in the query string or in cookies. The thing to remember with that is essentially you're handing the state over to the client and giving the client the opportunity to change it in any way they like before they send it back. Now, depending on what that state is, you may or may not care if the client tampers with it. Taking an obvious example, if you're writing a banking application that maintains the client's current balance in a request parameter that you push out to the client and let them alter freely before they send it back, and you just take whatever they send back without validation, you are going to lose a lot of money, probably quite quickly. So if you're going to do that sort of thing, then there are ways of handling that. You can encrypt the state before you send it out. You can digitally sign it if you're only worried about it changing. Lots of different options. Your framework of choice will probably have several of these options. But generally, the less state you can keep, the simpler things are going to be. The smaller you can keep it, the less often it changes, the better. But load balancing obviously has to be impacted by the state, because depending on where the state is being maintained, you may or may not need to take that into account when routing the next request from that client. If you're pushing it into the request parameters, it doesn't matter. The request can go anywhere. If you're maintaining it in an HTTP session, then it's going to need to go back to the right node. So we talked about sticky sessions. So you'd use that with HTTP sessions, and normally you'd use the session ID. This is what Tomcat will do by default to identify which the backend node is. So Tomcat does something very simple. It just appends a node ID to the session identifier when it's generated, and then that gets sent to the client. When the client sends a session back, the load balancer looks at that session ID, looks at the bit on the end, says, that's the right node, and routes it accordingly. I found out the hard way that if you incorrectly configure your node to name itself as the wrong node, your cluster will behave very strangely. If you're seeing really odd behavior and you can't figure out why on earth is this request going over there, just check that your nodes and your node labels and your load balancer are all configured consistently, because I've managed to swap a pair once and it took me ages to figure out what was going on. So be careful with that.
We had somebody copy the server mix from one server to the other.
So you have nodes with the same. Oh, even better. Lovely. So only half your requests disappear. Yeah, it's easily done, really easily done. Some apps will do this with a dedicated cookie. And again, you can do stuff with the client IP, but we've already talked about the risks. That typically the session ID is the method we see being used. We talked about account number and account type, and really there's always a overlap between how state's managed, what you're linking to, and the load balancing algorithm, because again, it's where actually is the state, and I need to make sure I route the request back there, or is the state all in a database and I just access it by an account number so I don't care? It depends. But there's always going to be some sort of relationship between the load balancing algorithm and the managing the state. It's something you have to think about together. You can't think about them completely independently. So what happens when things go wrong? Well, the load balancer needs to know the state of the nodes. Now, if you're doing this in a planned way, you know about it in advance, you've got several options for how you handle that, so you can handle it gracefully. When you get an unpredictable failure, well, you obviously don't know about that in advance. It's unpredictable. So how's the system going to behave? How's it going to detect it? How's it going to handle it? What's the impact going to be on the users? So if we look at maintenance first of all, you can make this more transparent to users. You can make it completely transparent if you want. Generally, the more transparent you want to make it, the more work you're going to have to do. If you're in an environment where, okay, well, if the users lose their session, it's actually not a big deal. They just need to log in again. Then you might say, no, I'm just going to take the node down. No warning, no nothing, just take it down, and those affected users can just log in. If you're in an environment where you do that and users are going to lose the best part of half an hour's work, you're probably not going to do that. And then you want to look at options of, well, I want to take that node down, but I don't want to harm any of the existing users. So what you can normally do with your load balancer is say, okay, existing sessions can carry on that node, but take that node out of the list of options for new sessions. So your new users slowly get distributed to the other nodes, and hopefully the sessions on that maintenance node die off. Unless, of course, your app does something like ping the session every 5 minutes to make sure the session doesn't expire, at which point that node's never going to die off, and you need to try and find other ways of handling it. So if you do go down sort of the node draining option, well, one of the things you've got to decide is, well, how long do I let those current sessions, how long do I give it to die off before I just say, okay, I'm going to have to shut the node down anyway? At some point you are probably going to have to do that. Something to think about is, can Tomcat's parallel deployment help? Because often the reason a node is being taken down is because you want to upgrade the app that's there. Well, there's a way of doing that without taking the node down at all, which is parallel deployment I mentioned this morning. So what that lets you do is deploy another version of the app in parallel. Any user that's got a session for the existing version of the app will carry on using that version. Any new users will use the new version of the app. And again, hopefully users will slowly come off the old version and switch to the new version. And you can even have Tomcat undeploy the old version automatically as soon as all the users have disappeared. That can often save you quite a lot of maintenance hassle, because it just happens. It'll even work over a cluster. If you've got cluster deployment, we'll talk about this a little bit later, and the app's deployed across the whole cluster, you can do parallel deployment through that as well, and it all works. As far as Tomcat's concerned, the separate versions of the app are completely independent applications. They just happen to have the same context path, and it routes things according to the version identifier, which it picks up from the session ID. But certainly something to think about for the maintenance downtime when you're just doing an app upgrade. It's the unexpected failovers where a little bit more thought is required. Typically, there's no management channel between the back-end servers and the front end. You can get mod cluster from Red Hat that adds a lot more information, so the front end is very aware of what's going on. There's the HTTPD thing, whose name I can't remember, that does a similar sort of thing but on a smaller scale. But really what you're trying to do is detect a failed node so you can fail over. And the question is, well, how do you detect a failed node? Well, you could use a failed request to detect it, but that raises a whole bunch of different problems. If you get a 500 response on a request, is that because your server's just crashed horribly with an out of memory error, or have you just hit a random application bug and the server's absolutely fine, it just had an internal error and it reported it as such? The load balancer probably can't tell the difference. Have you had a timeout because the server's crashed and the Tomcat process isn't running anymore? Or has your user just hit a particularly long-running request? Long-running requests are particularly problematic because if you know that they might happen, you have to configure the load balancer to allow at least that long before it decides that a request has timed out. So if your longest running request takes 20 seconds and your node goes down, that load balancer is going to keep sending requests to that node for another 20 seconds, and they're all going to disappear into the ether until the first timeouts happen. Then it will start switching it over. So generally the message there is using some form of user-initiated request to work out whether the back-end node is working is generally not the best way of doing things. It's better than nothing, but there are better solutions. Those better solutions are things like have a load balancer do regular requests to a known, simple page that you know is going to respond within a fraction of a second. It's your typical page that just returns a text OK, or maybe doesn't even return any content, it just looks at the 200 response code. Something just says, yes, I've had an HTTP transaction here, that the server is clearly still working. They're more reliable, you can have shorter timeouts, so you can detect failures faster, but it's still an HTTP request with the associated overhead. If you're using AJP, then you can use the AJP protocol ping to do it, which is just a handful of bytes. And there's a lot less overhead in that. So pros and cons of different options. So that's a relatively quick canter through load balancing. And now we're going to extend that and talk about clustering. So there's our reverse proxy. Then we move on to load balancing, and then clustering essentially, in the Tomcat sense of the word, means, okay, we have shared state here. We replicate the session state somehow, so this node has an idea of what's going on this node. The idea being that if this node fails, these nodes can somehow take over without the users noticing, mostly. So the idea is that the failovers become transparent. However, that transparency comes with a cost, and it's usually quite a heavy one. Pretty much the first question, we'll come on to the first question, when to cluster. Just get through here. So it's when to cluster, we'll look at the components, we'll look at options for some of those components, talk about some failure modes, and again, questions as we go. So when to cluster, ideally don't. If you can avoid it, don't do it. It is going to make things more complicated. It is going to require increased resources, both in terms of hardware, network bandwidth, memory, you name it, you're going to need more of it. Is the cost of providing all of that really worth the benefit you're getting from it? And this really goes back to looking at what the app's doing, looking what value the app's providing to the business, and saying, actually, if once a month somebody in finance needs to spend 10 minutes re-entering a column of figures because the app's just failed, well, that's mildly annoying, but 10 minutes of their time is a heck of a lot less than how much we'd need to spend on the hardware to implement clustering so that didn't happen. And in that scenario, you might decide, well, actually, no, we're not going to cluster. If say you're an insurance organization and you're running a website that does quotes for car insurance. Car insurance is notorious for asking you question after question after question. It takes you forever to fill the flipping form out just to get a quote. And as a customer, if that died on me halfway through, I'm probably not going back. I'm probably not going back there for quite some time. And that might have a significant cost to the company, because they haven't just lost the ability to give me that quote, they've potentially lost me as a customer for a number of years. Okay, I'm the sort of person that will go and find the cheapest place anyway, but more loyal customers than me, that might be a problem for them. That might be a different financial decision. It might not. They might say, actually, the failures don't happen that often, we can afford to lose a few customers, it's not ideal, but it's still cheaper than putting the hardware in place. But what you need to do is look at that equation for your particular environment, and you probably need to do it almost app by app, because different apps could easily have very different pros and cons. So do look very closely at implementing it before you do. And the other thing to bear in mind is when it goes wrong, it's an awful lot harder to figure out what went wrong and why. Not impossible, but there's a whole other layer of complexity going on. And depending on how you've configured your cluster, that you can control how much complexity is involved there as well. Load balancing with sticky sessions is probably enough for most cases, and generally clustering is the option of last resort. So this is a sort of overview of what the Tomcat clustering implementation looks like. So you've got the cluster, which is the configuration component that ties it all together. Then you've got the manager. That basically controls how the data is replicated. The channel, that does all the replication, so the sending and the receiving. And then you've got listeners, valves, and the deployer as separate components. And we'll just look at those each in turn briefly. So cluster, it's the container really for all the other related configuration. And you can place a cluster either in an engine or a host. If it's configured in a host, then you have potentially enabled clustering for all of the web applications for that host. If you configure it at the engine level, you've potentially enabled clustering for all of the web applications for all of the hosts in that engine. Before Tomcat will actually even think about using clustering, the web application has to be marked as distributable in web.xml. If it's not marked as distributable, Tomcat will not cluster it or will not replicate the data. So it's the manager, as I said, that controls how the data is replicated. That's what sets the replication strategy. You know, how many copies am I going to have and where? Channel, as I said, that's the communication between the cluster nodes, and the channel's got 4 components. There's one component that tracks the membership. Basically, that's nodes joining and leaving the cluster, so it knows where to send the replication messages, which nodes are in the cluster, which ones aren't. And also, depending on the implementation, sometimes the cluster, when it knows a node has failed, will take actions automatically in order to maintain the level of resilience that it's meant to retain. So not only does tracking the cluster to do with replicating the messages, it may take additional action on top of that to restore the level of resilience that you'd expect. So it's kind of obvious, the senders receive the messages, the receivers receive them, but you've also got these things called interceptors, which basically are components that every message goes through, and then you can basically do things like count the number of messages, count the number of bytes, filter the messages for particular scenarios, add functionality, block certain messages, all that sort of stuff. In terms of listeners, there are dedicated cluster listeners that will receive messages, things like node's gone away, new node's been detected, that sort of thing. Also, the managers support the Tomcat standard listeners, so you'll get they can get notified of when it starts, stops, is paused, is created, destroyed, and so on. And all of the session listeners, the ordinary ones you get in the Java servlet spec, they're supported as well. The valves, they're inserted into the request processing pipeline. They're there in particular to handle ensuring that the right node label is added to the session ID. So it's the valves that just, new session, hasn't got the node label on the end, just pop the node label on the end. They also spot when a request has been redirected. So if node A is failed and a request is redirected to node B, the session identifier that comes through to node B will still have .A on the end of it. So that valve will say, right, this session has now moved to this node, change that so it says .B, so it always comes here in future, so we maintain the sticky sessionness. And the deployer, that's the component that lets you deploy a web application across an entire cluster. To be honest, not that many people use it. I think partly because it wasn't massively reliable when it was first implemented. Discovered a lovely little bug when we looked into it, in that it split the application up into multiple messages and sent them out across the cluster and reassembled them at the other end. It just didn't check it reassembled them in the right order. So the bigger the app was, the more likely it was not to reassemble correctly at the other end. But once we got that fixed, it works a treat, and as I say, it just worked with parallel deployment. So that is there if you want to use it. It's just not as widely used as you might think. So if we go on to look at the managers then, and our options for how we replicate data across the cluster. So the default is we have everything replicated everywhere. That's great in terms of reliability. It's really bad in terms of scalability, because if you sit down and do the maths, as the traffic grows linearly in terms of requests, the network traffic for the clustering grows with the square. So very quickly you run out of bandwidth. It does not scale very well. How many nodes it will scale to will depend a lot on how big your sessions are, how big your session objects are, how much data you're pushing around. I'd start to get nervous probably if I got to about 4 nodes, and the more you go above 4, the more nervous I'd get. But But the advantage of this approach is when a node fails, any other node is in a position to take over because they've all got a complete copy of everything. Obviously, because they've all got a complete copy of everything, they all need enough memory to hold every single session across the entire cluster in memory. So your memory requirements are potentially quite big. The backup manager is very often misunderstood. I've had people stand in front of me and tell me I'm absolutely wrong, and no, the backup manager doesn't behave the way I think it does. Trust me, it does. The backup manager, there is not one backup node where everything gets backed up to, but that is a very common misunderstanding. The way the backup manager works is within the group of nodes, one node is identified as the primary node, the other node is identified as the backup node. And the backup node is always chosen on a round robin basis by the primary node. So there is no single backup node. There is no single place where everything's backed up, everything's distributed. However, every node knows the primary node and backup node of every session. So there is effectively a session map for all nodes on every node, but most of them just say the primary's over there, the backup's over there. Some of them will say, right, this is the primary node and here's the session data. Some will say this is the backup node, here's the session data. But in a big cluster, the bulk of those pointers just say, yeah, backup over there, primary over there. And because there's basically one copy on the backup, then the network traffic is basically directly proportional to the number of requests. So it grows linearly as the requests grow. So in terms of scalability, things are a lot better. However, understanding what happens during failover is a bit more complicated. Question?
So, can you have multiple backup nodes?
No.
So you can only have one?
Yes. But the cluster is self-repairing, which we'll come on to in a minute.
You still, they both go down at the same time?
Oh, if both go down.
If you've got like 100 nodes in your cluster.
Yeah, if two of them go down at the same time, then you are, as they say, stuffed for those sessions. Well, for the sessions where the primary and the backup were across those two, which will actually be, say you've got 100 nodes, will be 1%. Yeah. So it's a small number, but yes, it's a risk. There is, of course, these are the two backup manager implementations that are provided. You are, of course, free to implement your own. We don't see it happen very often. When we do tend to see it is more for hooking in we actually see ordinary session managers implemented, and they then hook into some other back-end store, sort of key value database or something, or a large in-memory database, but they tend to hook in at the standard session manager because the back-end store handles the failover, the recovery, so Tomcat doesn't need to worry about it, so it doesn't need to cluster. Anyway, failover is more complicated, so we'll look at an example. So here we've got a perfectly distributed, and actually the way the algorithms work, even on a normal system, it tends to end up pretty much like this. So we've got 4 nodes, A, B, C, and D. So on node A, it's got 30 primary sessions, and of those, 10 are backed up on B, 10 are backed up on C, 10 are backed up on D, and the same for the other nodes. So each node ends up with 30 primary sessions, 30 backup sessions, and across the entire cluster, we've got 120 sessions there. So let's say node D goes down. Before another request is received, the cluster will have said, right, we know that node D has gone down, so B will make itself the primary for those 10. A will make itself the primary for those 10. C will make itself the primary for those 10. They'll then say, oh, but hold on. These 10 new sessions I'm now the primary for, they need a new backup. I need to distribute those backups, so it will then split those backups. A will split its backups between B and C. It'll also say, oh, I also had 10 sessions backed up over here. They need to be backed up somewhere else. So those 5 will get distributed between B and C as well. So without anything else happening, the cluster will start the process of replicating everything around to get you back to a state where you've got a primary and a backup. Now that does mean after a node failure, you get a big spike in network traffic. So that's what we've just talked about. However, we don't just end up at this state. Well, we will end up at this state, but there's quite a large but. So we've now got 40 on A, B, and C, backup's evenly distributed. So we've still got our 120 sessions. We've still got 2 copies of everything. We've just now got 3 nodes rather than 4. However, and it is quite a big however, at the same time all of that is happening, the load balance will know that node D has gone down as well. And it's going to redistribute the requests that were heading towards node D. The problem is that the load balancer isn't necessarily going to make the same choices about where to distribute those sessions as the cluster just made. So what will happen is that when a node receives a request for a session it is not the primary for, it will make itself the primary. So you actually get a little bit more network traffic and there's a little bit more shuffling around of things than you would ideally want. But without some sort of communication between the back-end load balancer and the cluster, there's really no way to avoid it. So there will be a bit more moving of the primary, but the end result is ultimately you end up in the same position where the sessions are evenly distributed across the cluster and you've got a primary and a backup.
What happens when node D comes back online?
When node D comes back online, the load balance will start to send new sessions its way, and so it will then spread its backups over the other ones, and then it becomes eligible in the round robin again for new sessions on the other nodes, so it will slowly ramp up its load. There isn't another big switcheroo. It's only when you have a failure that happens. Again, if you want another big switcheroo, you don't even need to write your own. Take the one you've already got, just take that and just edit the Tomcat one and package it in your own class. And it's not something I would generally recommend, but you do always have an option if there's a pluggable Tomcat component, and most of them are. If it's not doing quite what you want, there is always the option, and there isn't a configuration option available. The options to you are live with it, ask us to add a configuration option to do it. Normally we say yes. How quickly we do it depends on sort of how likely we think other people are going to want the feature, or just copy the component, make the change you want to make and deploy a custom one. Now that does carry ongoing maintenance costs, but depending on what the change is and how much you want it, it might be worth doing. Right, getting back to cluster membership then. 2 ways of managing membership at the minute, either multicast or static, and they've both got pros and cons. For multicast to work, obviously multicast needs to be enabled on the network, and that's very much dependent on your environment whether or not that's actually possible or not. On internal networks, private clouds, it's probably doable. Public cloud, maybe not. You can start to get into games of setting up private networks and stuff, but it's maybe. It can be a little bit difficult to figure out what's going wrong, because you need to monitor all of the multicast traffic to work out, well, why did that node disappear? Well, you need to see all the traffic there to see what's going on, but it does scale more easily. And the reason it scales more easily is you just add the node to the network with the right configuration, and it joins the network and it sorts itself out. From a security point of view, that has some disadvantages. Essentially, the general rule as we were talking about earlier is that the expectation is that the cluster network is secure and is trusted. If that's not the case, then there's all sorts of opportunities for nefarious activity. Not only will a node be able to see a large chunk of the session data, it can inject sessions of its own, it can inject malicious payloads, which will almost certainly trigger remote code execution problems on other nodes in the cluster. It is very important that cluster network is maintained as secure. Static is easier to figure out what's going on, but it just doesn't scale quite as well, and that's simply because if you've got 2 nodes and you want to add a third, well, that's not too bad. You've got 1 new configuration to write and 2 to change. If you've got 20 nodes and you want to add another 5, that's 5 new configurations to write and 20 you've got to go back and change. So the bigger the cluster gets, the more nodes you've got to edit every time you want to add another node, and it just starts to get unwieldy. Not impossible, and if you automate it with tooling, and it's not too bad at all, but it can, if you're doing it manually, it's certainly more time consuming. Now, the next thing, having decided on which manager you're going to use, how you're going to manage your membership, is about send options. Now, this is one of those historic things in Tomcat that we are trying to iron out, but this one we haven't got rid of yet. This configuration option is called Set Channel Send Options, and it's on the cluster for the Delta Manager. It's called Map Send Options, and it's on the Manager for the Backup Manager, but it's essentially the same thing. The fact that they've got different names, the fact they're on different components is less than ideal, but historically that's the way it evolved, and we haven't got around to fixing it yet. And you've got a couple of choices here. First of all, do you want the data to be sent synchronously or asynchronously? And this is all to do with when I need to update a session on another node in the cluster, how do I do it, when do I do it, how quickly do I do it? So if you do it in a synchronous manner, basically the request processing for the current request will not complete until the session data that's changed in that request has been sent to the other nodes in the cluster. Which kind of raises the obvious question, what exactly do you mean by sent in that scenario? And the answer, well, it depends how you configure it. You can say, well, as long as it's been written to the TCP stack, that's good enough and we'll carry on. As long as the other nodes have received it, that's good enough. Or as long as the other nodes have received it, processed it, and acknowledged it. So really that last one is the only one that says, yes, I know the other sessions in this cluster have been updated before I let this request complete. And the reason that this is important is, again, it's to do with how your load balancing is configured and what happens sometimes on failover, but particularly with load balancing. If you're in an environment where, say you're using the Delta Manager, so everything is replicated everywhere, you could in theory let any request go to any node and have a very simple load balancing algorithm. But if you go that route, you need to make sure that every request replicates all of its data to the other nodes before the next request is processed. Otherwise, you're going to end up with request 1 happens, request 2 happens, but request 2 doesn't see all of the session updates that have happened in request 1 because request 1 completed, allowing request 2 to start, before request 1 had actually replicated all of its data to the session. So in that scenario, you'd probably want to set the option where you make sure the session update is processed by the other node before you let the request complete. The other thing to bear in mind is that browsers often issue requests in parallel, normally for static resources, but depending on what's actually going on in your app and how your app behaves, that may or may not be an issue for you. So even if you've got a cluster, there is actually usually a good reason to use sticky sessions, because it keeps all of the requests on the one node, so you know that, okay, yes, I've got session updates replicating out, but any requests that hit that node are always going to see the latest data. If you go the asynchronous route, so you say, yeah, no, fine, just process the next request, just stick the session update in a queue and get around to dealing with it eventually, then you absolutely are going to need to use sticky sessions. Because if you don't, there's a very good chance a request to another node in the cluster won't see the updates. The other thing to bear in mind is that updates may not be received in the same order that they're sent. Well, they'll be received in the same order because that's the way networks work, but they might not be processed in the same order. And that's because you tend to have a thread pool processing messages. So if you've got 4 messages in the incoming queue, you've got 4 threads, they'll take a message each, and at that point it's up to the scheduler to decide which one of those threads actually executes first. So the messages may not get processed in the same order that they were sent. So with asynchronous, you definitely want sticky sessions. And something to bear in mind is because the session updates are being put in a queue, if the node fails, those updates are probably going to be lost. At which point you'll fail over to another node in the cluster, but not all of your session updates will be visible, which might cause unexpected behavior for your users again. When it comes to debugging this, when it goes wrong, it can get quite complicated quite quickly. If you're trying to set a cluster up, what I usually do is I've got a little test web application that will display the current session ID, the current route, the name of the node that handled the request, and possibly some data from the session as well. And then I can then check that load balancing is behaving the way I expect it. So if it's doing round robin, I just hit there going refresh, 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 and I should see the current route change. I should see the node that handled the request change. I can inject data into the session and ensure that that's replicated as I go around the nodes. You can do things like, well, if I fail that node, check that I fail over to this place where I expect to. So that simple web app, and it took me about 5 minutes to write, so it's dead easy to knock up. It's just a JSP. Is very, when you're trying to debug a misbehaving cluster where something isn't quite right, it's really helpful because it gives you all of the information you want right there in the browser. And really, when the configuration isn't behaving, it's basic sanity check time. Is the route that I'm seeing correct for the node that I'm on? Is load balancing happening as expected? So is it going around the nodes in the round robin order you'd expect, or whatever order you would expect based on your algorithm? Is failover happening as you expect? And when it's not, it's then a case of, well, what did I expect to happen? What actually happened? Okay, what could have caused that? And that will normally point you towards the configuration issue. And it's usually some around the routes. The route's not being set correctly, the IP address is not being right, something around there, you haven't quite got that lined up. But do keep in mind when you're doing all of this, how your reverse proxy or load balancer of choice handles failed nodes. If you're using HTTPD, for instance, by default, once it detects a node's failed, it keeps it marked as failed for at least a minute. So if you're doing a test where you take the node down, you see the failure, you bring the node back up, it ain't going to start using that node again for another 60 seconds. So you need to bear that in mind when you're doing your testing, and don't say, yeah, node 1 down, back up, node 2 down, back up, node 3 down, back up, node 4 down, back up. Oh, HTTP thinks every single node is down. I'm getting 503s for everything. Definitely not what it's quite easy to fix. We'll just do a graceful restart of HTTPD and everything will be fine, but not what you want to be doing when other people are trying to use the cluster as well. If it's the application that's having a problem, then it's going to be difficult. It's just like debugging any other application issue, but it's harder because you've got a cluster and you need to understand what the interactions are. First thing I would always say is try and reproduce the problem in a standalone, non-clustered environment. If you can do that, you take away a huge chunk of complexity and make your life a lot easier. If it can't, then how you approach it is really going to depend on the application. There are some general rules. If it looks like it's to do with the network or failover, look at access logs. Again, make sure you've got an access log for every node in the system and every tier. So certainly I've seen in some environments you've got a front-end hardware load balancer, then HTTPD, then Tomcat. If something odd is going on, I would want access logs from every single layer in that, so I could actually trace requests through and see where problems were happening. I do look at the error logs. You might need to look at the network traffic. I've come across this once or twice. We had an issue where in a load balanced environment, a user session was getting dropped and we couldn't figure out why. And we did some debugging and we found that the application was dropping it because it detected a dropped connection. And it was a fairly paranoid banking application. They said, well, if I have a server disconnect, that shouldn't happen. So I'm going to drop the session and force you to log in again. As I say, it was quite paranoid. But what we couldn't figure out was, well, why is the server dropping the connection? This makes no sense. And it wasn't until we looked at the network traffic we figured out what was going on. And it was good old Internet Explorer. What was happening was the server was quite correctly, the load balance was closing the connection normally, standard TCP close. Internet Explorer was then trying to take advantage of an IIS specific feature that even if IIS says, oh, close this connection, it'll let Internet Explorer carry on using it and effectively reopen it, which it was trying to do with HTTPD. which took one look at the packet, not a chance, TCP reset, go away, that's crazy. Which Internet Explorer was then receiving, seeing that as a drop connection, and the application was saying, oh, right, oh, there's some sort of security strangeness going on here, I'm going to kill the session. But it wasn't until we looked at the Wireshark traffic, we could actually see what was going on, and then we were able to dig back and find out, oh, I never knew IIS did that. Oh, and then we found the option that we could disable it, and it was all fine again. But that was 2-3 days I spent in the City of London trying to dig that one out. What made it more interesting was it was one of the international banks, so we had the servers were in one country, the clients were testing from another country, we were in a third, and what I needed was Wireshark traces. Yeah. Oh, and I think they were encrypting everything as well, just to add to the fun. So it's not my preferred option, but it is an option. Generally better if it's a problem with the application, logging. Now, this is something that's, before things go wrong, it can be quite hard to figure out, well, what logging do I need, what logging don't I need? And one of the things that Tomcat has benefited from, again, it's one of these slow things we improve over time, is when I'm debugging a network bug, some sort of I/O bug, I normally throw all sorts of random debug statements all over the code, but the ones that turn out to be useful get put in properly so I can turn them on again next time. So the first time I have to solve it, it's normally a bit harder, but the next time is easier, and the time after that's a bit easier. So yeah, put in the logging you think you're going to need, but always try, if you can, be prepared to put in extra logging, and then keep the stuff that's useful. And you definitely need to be able to fine tune it. Having that level of information, particularly if it's an application problem, then that's a big help. The other option, which I'll use for Tomcat, is the good old remote debugging option. But again, that isn't always something you can do in production. So that did quite well for time. Brings me to the end of the second part of the reverse proxies, load balancing, and clustering. Do we have any other questions that you haven't asked as we go along? Going once. It is. In which case, thank you very much, and I'll hand over to John Frederick.